yeah, Mom made sure we had our school supplies. We are not starting in the packet, folks. Not starting in the packet. So let's get out our notes and our pencils. Everything we do is in pencil because once in a while we make a mistake and we need to erase. A lot of what we talk about in the coming days is going to be review. So I apologize. Please try not to be bored. Try to hang in there. The first thing we're going to start with today is what is called interval notation. You are all hopefully going to take some advanced math class like calculus, and your answers for the most part will be written in what is called interval notation. So for example, if we had a problem like this, and the direction said solve it. Well, everybody in this room knows you're going to subtract 2, right? And you're going to divide by 5. By the way, while I'm here, remember in an inequality, there's a special rule for division. What's that rule for division, Jason?
Divide by a negative, flip the sign.
Exactly. So if this had been a negative 5, then that would turn around to a greater than. Everybody remember that? Okay. Now, at some point in your life, I don't know whether you could write your answer like that. Sometimes we use what they call set builder notation. That looks familiar, maybe, I don't know. But what we do when we're big kids is we write our answers as an interval. Now, if I were to graph this on a number line, I would have an open dot at 1, and I would shade everything this way. Would you agree? An interval describes everything that you shaded. So, reading left to right, which is the way we read, where does this shading start? Negative infinity. Where does the shading end? 1. This is an open situation. The circle is open. Infinity is never included. If there were an infinity out here, it would have to be an open dot because it never stops, right? It keeps going, 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 going. So we use the open interval notation. That looks like an ordered pair. So occasionally you will see it written this way. Now I will probably be using this notation most of the time, but it might be that you run into it like this because some people prefer this so it doesn't look like an ordered pair. Now, what if the dot had been closed in? For example, what if we had something like this? Now, if I were going to put that on my number line, this is called compound inequality. It tells me 2 things about x. It says x is bigger than negative 5, and x is less than 8. So on the number line, here's negative 5 and here's 8. I'd have a closed dot, right, because of the or equal to, at negative 5, and an open dot at 8. Would you agree with me? And I'd shade everything in between. Now, as a set, that's what it would look like. That's the answer to the question. That's what the points are that we're concerned with. In an interval, we would use a bracket to indicate that the negative 5 is closed, and we would use our parentheses or our little arrow thing to indicate that the interval is open. Is everybody okay with that? Okay. So, if I said to you, could you give me the answer to that compound inequality in an interval form? So can you solve that inequality and write your answer as an interval? The answer is absolutely you can. First of all, we're going to add 1. But when we add 1, we're going to add it to everything. So now it says 11 is less than 3x is less than 41. And then guess what we're going to do? We're going to divide everything by 3. Oh no, there are fractions. Yes, fractions happen in the real world. Now I want that as an interval. What will that look like as an interval? Well, what symbol? I got my 11 thirds and I have my 41 thirds. And oh, by the way, when you write those down, make sure they're in order, little big. Now, I need a symbol here. Am I going to use my bracket or am I going to use my parentheses in this problem? Parentheses. There's the answer to the question. Now, do you remember doing problems where you ended up with an answer that looked like this? X is less than 5 or X is greater than 7. Remember getting answers that looked like this? It wasn't even really that, make it a little more wild. How would I describe that as an interval? Well, what does it look like on the number line? Here's 5, here's 7. There's a space in between them. So I'm going to have I'm going to have open dot at 5 and shade this way. I'm going to have a closed dot at 7 and shade this way. Right? How do I write that as an interval? Any thoughts on that, Jason?
You do them each separately and then connect them with a U.
Oh, so I do this one separately. We did one of these already. I think I may have just erased it. This would go from negative infinity to 5. Everybody with me? And those would both be open. Please remember the infinities are always open. Infinities, and when we get to it, asymptotes are always open. And then this one, okay, now this one is going to have a closed at 7, but an open at its infinity. Is that all right with everybody? And then Jason said put a U in between them. Anybody know why he would say that? Anybody know what that U means or why we would put a U in there? What's that stand for? Oh, come on now. Somebody knows.
Isn't it a union?
It means union. It means union. And what does union mean to the mathematician? I mean, what are we really saying? It's either this piece of the number line or it's this piece of the number line. And anytime you're trying to represent two pieces or more, you're going to separate each individual interval with a U, a union. Because you're taking this set of points or this set of points are included in the answer. Very good. Anybody have a question about that? Okay, quickly then, can you tell me what I mean when I say I have a rational number? Can you tell me what I'm talking about when I say I have a rational number? Somebody, I mean, I love Jason, but is there anybody, anybody else that has any idea what a rational number is? Yes, Max.
Is it just the regular like 1, 2, 3, 4, 5?
Well, I'll tell you what, 1, 2, 3, 4, 5 are included in the rational numbers. There are more numbers than that. These are actually called the natural numbers, or sometimes the counting numbers, because when you're a baby and your mom sits down with you and says, honey, we're going to learn to count today, how do you count? 1, 2, 3, 4, 5. That's what you do. So these are included in these. Yep. There's more, though. There's more included. Michael?
Isn't it like a non-repeating number?
It can... Okay, we have to be careful. What do you mean by a non-repeating number?
Like
Okay, 1/3 is a rational number, you are right. But it is not a non-repeating number, it is a repeating number. Yes, so a repeating decimal. Is there any other kind of number besides a repeating decimal that would be rational?
Are whole numbers?
Well, right here, the whole numbers are actually the same set as these, except we add 0 in. You'll remember that because 0 has a whole in it. So these are the ones you naturally learn when you start counting. When you throw 0 in, got a hole in it, now you got the whole numbers. Are these numbers decimals? Can these numbers be written as decimals?
Yeah.
How would you write 2 as a decimal?
2 over 1.
Well, as a fraction, it would be 2 over 1. As a decimal, it would be 2.0. If you are a repeating or terminating decimal, you are a rational number. Now, this is important because we need to be able to go back and forth. This is a repeating or a terminating decimal, is a rational number. Now, Jason was talking about fractions. If you can write the number as a fraction of 2 integers, in other words, 2/5, 7/8, 12/7, those are all rational numbers. If you typed these into your calculator, you would get either a decimal that repeats or a decimal that terminates. You know what terminates means? Stops. These are rational numbers. So then, what is not rational? Oh no, negatives are included. These could be, that doesn't make any difference. They can be positive or negative, rational numbers. What would be not rational?
Imaginary.
Well, imaginary, definitely not rational. We've gone into a whole different realm then. Rational numbers are real numbers.
Non-repeating decimals,
Non-repeating decimals. Can you give me an example of what you mean?
like pi.
Pi. Pi, the square root of 3, e, all of those are irrational. Because when you type them into your calculator, you get a decimal that doesn't ever stop and it doesn't ever repeat. Isn't that mind-boggling? That is mind-boggling. I'm going to show you. Someone gave me this last year when I had no hair at all. This is my pi star. These are the digits of pi. Look at that. See how small that type is? And it just goes on forever and ever and ever and never repeats. Isn't that remarkable? It just makes me, oh, it cheers me up. It makes me so like in awe. Is it time to go? I hear how all said they're talking. Who's got the schedule? It is. God bless you all. Have a wonderful day, and I will see you tomorrow. Be sure to keep your eye on Schoology for those assignments, but you've got a hard copy.